The next concept with respect to DC to DC converters is start with types of choppers based on quadrant operation. Okay. Okay, all of you write down this types of choppers based on quadrant operation. The types of choppers based on quadrant operation. This one concept. Yes. Based on quadrant operation, the choppers are classified into one is type A chopper, type B chopper, type C chopper, type D chopper, type E chopper. Okay. Type A, type B, type C, type D, and type E chopper. Yes. Sometimes it is also remembered as a class A, class B, class C, class D, class C. That is also correct. Type A is first quadrant used for forward motoring. Type B is second quadrant chopper used for forward motoring and forward braking. Type C is first and second quadrant. This is forward braking on. Okay. This is first and type C is first and second quadrant used for forward motoring and forward braking. Type D is first and fourth quadrant is used for forward motoring and reverse braking. Type E is first, second, third, and fourth quadrant is used for forward motoring, forward braking, reverse motoring, reverse braking. That means 4 quadrant chopper. This is one way to remember to answer theory questions. 4 quadrant chopper. In which quadrant it is operated, in which application we can use. Like that questions are asking in some competitive exam. 1 or 2 theory questions even in GATE exam also. To answer that type of questions, this remember directly. But in detail analysis is how type A chopper is operating first quadrant, how type B is operating second quadrant. That is in detail analysis I want to discuss. For example, and this analysis also useful if any one chopper circuit is given. You don't know about that chopper circuit. Is it a type A or type B or type C or type D? You don't know about that circuit. But if any one chopper circuit is given, for the chopper circuit shown in figure, in which of the following quadrant it is operated, if the question is asked like that, then by analyzing that circuit, you want to prove that in which quadrant it is operated. To solve that type of questions also, in detail analysis of types of choppers and based on quadrant operation is useful. Okay, now we'll see what exactly type A, how it is operated in first quadrant, where it is used. All these points I want to discuss. Okay, now this in detail analysis is useful by your own, how to analyze the circuit and how to identify in which quadrant it is operated. For that, this analysis is more useful. Okay, shall we start with the first one is type A chopper. We start with type A chopper. type A chopper. And first draw the type A chopper circuit. This is switch or chopper. This switch or chopper, and this is diode connected across the load, and load is connected. Okay. And this is I naught. This assumed load current direction. This assumed load polarity. This is chopper or switch. Chopper or switch. The supply voltage is VDC. This plus minus. This is freewheeling line. Okay, this simple representation of type A chopper. The switch may be any semiconductor device. Now the question is, we want to analyze in which quadrant it is operated. To analyze in which quadrant it is operated, we assume that this is the assumed current direction, this is the assumed voltage polarity. Okay. During operation of this circuit, whatever the current supplied by the source is same that of assumed load current direction, and whatever the current supplied to the load is same that of the assumed current direction, then you take current is positive. If it is in opposite direction, take the current is negative. This one assumption. During this operation of this circuit, current supplied to the load is same that of assumed direction, take the current is positive. If it is opposite, take the current is negative. Next. During the operation of this circuit, whatever the polarity applied across the load, same that of assumed polarity, take the voltage is positive. If it is opposite, take the voltage is negative. Okay. Now, one operation is nothing but one on and one off. The total circuit can be analyzed one time period of operation. One time period is nothing but one on and one off. The first one is chopper is on. Chopper or switch is on. If the chopper or switch is on means what the diode, freewheeling diode is off state. Freewheeling diode is off. Okay. Now what is the equivalent circuit? Chopper is on. This chopper is on, and this is the equivalent circuit, and this is the load. This is the load. The polarity of source is VDC. This is plus minus. Tell. If the chopper is on, this is the equivalent circuit. Now this will supply the current like this. This is I naught direction. This positive is connected here. This negative is connected here. Okay. Now the current supplied to the load, same that of assumed direction. That's why you take I naught is positive. If the chopper is on, I naught is positive. Then this polarity, the voltage supplied to the load, same plus minus. This is also plus minus. Same that of assumed polarity. Take V naught is positive. Okay. But one operation is nothing but one on and one off. Na? This chopper is off. Tell. If the chopper is off, then what about the freewheeling diode? Freewheeling diode will on. Because of, let's assume that internally inductor is, that load is having some inductance. Because of inductance, that freewheeling diode is on. Now if the freewheeling diode is on, what is the equivalent circuit? Chopper is off. This freewheeling diode is on. This is a freewheeling diode. And this is load. Okay. Now this is VDC. This plus minus VDC. This is chopper or switch. Now see, what the current supplied by the freewheeling diode? The current supply, because freewheeling diode is connected like this now, this freewheeling diode will supply the current like this. Same that of assumed direction or opposite direction? Assumed direction. What is I naught? Positive. But freewheeling diode is connected, load is short circuited. Now, once the load is short circuited, what is V naught? 0. Now, resultant I want. One operation is nothing but one on and one off. That's total time period of operation. I naught positive, I naught positive. What about the resultant I naught? Positive. V naught positive, V naught 0. What the resultant? V naught positive. I naught positive, V naught positive. Which quadrant? First quadrant. First quadrant. Therefore, in type A chopper, I naught positive, V naught positive. It is a first quadrant chopper. This point is important. I naught is positive, V naught is also positive. Hence, it is a first quadrant chopper. First quadrant chopper. It is operated in the first quadrant. First quadrant chopper. In general, in the representation of quadrant operation, I told already, in the representation of quadrant operation, if it is not mentioned in which axis it is taken, generally you take V naught on Y axis, I naught on X axis. This is minus V naught, this is minus I naught. Then, hence it is the first quadrant chopper. In first quadrant means V naught positive, I naught positive. It is the first quadrant chopper. Okay. That means, in the case of type A chopper means in a type A chopper, what is V naught positive, I naught positive? Always I naught is greater than 0, V naught is greater than 0. That's the meaning. I naught positive and V naught positive means I naught greater than 0, V naught greater than 0. Tell. One more point. All these points important. V naught positive, I naught positive. What the power is? Output power is positive. Positive power means conventional power direction. Power is delivered from source to load. Power is delivered from source to load. Delivered from source to load. Source to load. Hence, it is used for motoring control. It is used only for motoring control. That is forward motoring control. In first quadrant, it is used only for forward motoring control. That is, type A chopper is used only for forward motoring control, FM control, forward motor. Only for to start the motor only we can. To start the motor in motoring mode only we can use this type A chopper. But motor can also operate in braking mode also. But type A chopper is not preferable for braking mode. Okay, this is used only for motoring control because power is delivered from source to load. Positive power means conventional power direction. Conventional power direction is always in the source to load. That's why we are delivering the power from source to load means it is a motoring, not a braking. Next, one more point. Power is delivered from source to load. Source to load. Power is delivered from source to load means what the source voltage generally we are taking here. Source voltage is VDC. Load voltage is V0. Power is delivering from source to load means in general power is delivered from high voltage to low voltage. That's why here power is delivering source to load means it is delivering source voltage to load voltage means load voltage is less. Therefore, V0 is less than VDC. V0 less than VDC means what is that operation? Step down operation. Hence, type A chopper is also called step down chopper. Therefore, hence, it is also called step down chopper. It is also called step down chopper. Type A chopper is also called step down chopper. Then it is a step down chopper means for type A chopper, the analysis is, most of the analysis is without filters you take. The analysis is similar to that of buck regulator, whatever I discussed. Then for type A chopper, what is V naught equal to dVdC? What again no need to derive. What is V naught RMS equal to root dVdC? Root d times of VDC. Then what is a form factor equal to V naught RMS by V naught, that you can get 1 by root d. Then what is the ripple factor equal to? Ripple factor equal to square root of 1 by d minus all these. Okay. Then the analysis is similar to that of buck regulator, but chopper I told. Chopper, what is the difference between chopper and regulator? Without filter arrangement, that is nothing but a chopper. Then we can get same formula, V naught equal to D. This points to it. That means in type A chopper, it is a first quadrant chopper. It is used only for motoring control. Then in type A chopper is also called step down chopper. What is the average output voltage? What is the RMS output voltage? What is the form factor? What is the ripple factor? Remaining analysis is similar to buck regulator without any filter arrangement. Okay, this you know. Quick. This is type A chopper. Like this, we are analyzing that in which quadrant it is operated. We proved that it is operated in the first quadrant. Okay, quick, no doubt. A type B chopper. How to analyze type B chopper circuit? Okay, first you draw the circuit type B chopper. At input side, it consists of one diode. This is chopper or switch arrangement. This you take RLE load. Okay. This is assumed current direction, and this is assumed voltage polarity. This is chopper or switch. Okay. Chopper or switch. Then you take this is VDC. This plus minus. And this is diode. This is type B chopper circuit. But one point to remember, for the operation of this circuit, load must be consist of battery. Then only this circuit operation is applicable. For this chopper operation, load must consist of battery. Load must be consist of battery. Otherwise, this operation will not applicable, because diode is at source side now. Initially, because of this polarity, diode is under reverse bias. Then how the chopper will be on? To start this chopper, it must be one energy L. This must be some battery at the load side. That's why for this chopper operation, load must be consist of battery. But one operation is nothing but a one on and one off. That you will see. Yes. Chopper is on. Chopper is on means chopper is on. Then what is diode is under off state? A diode is under off state. For the equivalent circuit, diode is under off state. This is chopper is on. And this is RLE load. RLE. The supply voltage is VDC. This is plus minus. Now switch is represented like this now. Then it supplies the current in downward direction. Then what is the current supplied by this chopper? You tell me. How this chopper is on? Because of this battery. If this battery is not present, this operation is not possible. Then this chopper will supply the current like this. This is opposite to assumed current direction. That's why I naught is negative. When the chopper is on means load is short circuited. What about V naught? 0. But one operation is one on and one off. Chopper is off. Diode is on. Chopper is off. Okay. Diode is on. How this diode is on? This diode is on because of E plus L into di by dt is greater than Vd. Because of energy stored in the inductor, then this voltage, this E plus L into di by dt is greater than Vdc. That's the reason why diode is on. Okay, don't think like this. Sir, here positive supply is connected. How the diode will on? Diode is under reverse bias and like that. Don't think. Here diode is on means because of the inductor and battery only diode is on. Okay. Without diode is on, how it is possible to design this circuit? Not. So we are designing this circuit means we are designing in such a way that this diode is on because of this voltage. Understood? Then E plus L in d by dt greater than Vdc. That's the reason why diode is on. If the diode is on, what is the equivalent? Chopper is off. This is load. Let this diode is connected like this. Now this diode will conduct like this. Then this is the supply polarity, plus minus. The diode will conduct like this. It supplies the current opposite to assumed current direction. Then what about I naught? Negative. Positive wire is connected here, negative wire is connected here. Plus minus, plus minus. Same that of assumed polarity. Then what is V naught? Positive. But you want resultant now? You want resultant. Then you tell me. I naught negative, I naught negative. Resultant I naught is negative. This resultant I naught is negative. V naught 0, V naught positive. Resultant V naught is positive. I naught negative, V naught positive. Which quadrant? Second quadrant. Second quadrant. This is the proof. That's why type B chopper is a second quadrant chopper. Type B chopper is a second. Now list out the points. I naught negative, V naught positive. What do you mean by I naught negative, V naught positive? I naught is less than 0, V naught is greater than 0. This relation is also giving in the options. I naught less than 0, V naught greater than 0. Then it is a second quadrant chopper. Second quadrant chopper. This is second quadrant chopper. Then I naught negative, V naught positive. Then what the power is? Power is negative. Power negative means opposite to conventional power direction. Therefore, power is delivered from load to source. Load to source. Hence it is used for braking mode. It is used for braking mode. It is used for braking mode. To operate the motor in braking mode, then we can use type B chopper because power is delivered from load to source. Power is delivered from load to source. Then power is delivering from load to source means, we know this. In the case of type B chopper, power is delivering from load to source. Load voltage is Vdc. Source voltage is, load voltage is V naught. Load source voltage is Vdc. In general, always power is delivered from high voltage to low voltage. That means V naught is greater than Vdc. V naught greater than Vdc. V naught greater than VDC means which operation? Step up operation. Hence, type B chopper is also called step up chopper. Hence, type B chopper is also called step up chopper. Is also called step up chopper. The analysis is what are the formulas I given step up chopper or boost regulator, that average voltage and RMS voltage, average load current, that formula it is applicable here. No need to separate. These points you remember here, it is a second quadrant chopper, then it is more favorable for braking mode, and it is type B chopper is also called step up chopper. If you represent quadrant operation, of type B chopper, this is V naught, this is minus V naught, this is I naught, this is minus I naught. V naught positive, I naught negative. This is second quadrant. Is used for forward braking control. Type B chopper is more favorable for forward braking control. V naught positive, V naught greater than 0, I naught negative, I naught less than 0. Then it is a which chopper? Type B. Quick note. Now see the type C chopper. Type C chopper. This type C chopper is also called two quadrant type A chopper because it's a modification of type A. That's why it is given as a, it is operated in two quadrant and modified from type A. That's why it is also called two quadrant type A chopper. The two quadrant type A chopper. It's a two quadrant type A chopper. Type C chopper is also called two because it's operating in two quadrant. Then what is the circuit of two quadrant type A chopper? This is switch or chopper arrangement. Diode. The load is RL. This is assumed current direction. This assumed load polarity. Okay. Then this is VDC. The supply voltage. This plus minus VD. This is CH1, CH2, D1, D. Okay. This is type C chopper or two quadrant type H. Yes. Listen please. By seeing the circuit, directly we can say that in which quadrant it is operated. Okay. If you think like this, if these two devices are not present, CH1 and D2 is not present, what this chopper you tell me? Yes. Switch is at source side and diode across the load. Then it is which chopper? Type A chopper. If these two devices are not present, what is this chopper you tell me? Yes. Diode is in series with diode is at source side, then switch across the load. If the switch across the load means, then what is this chopper? type B chopper. That's why it is a combination of type A and type B. Type A is operated in which quadrant? First quadrant. Type B is operated in which quadrant? Second quadrant. That's why it is combination of type A and type B, means it is operated in first and second quadrant. Understood? That directly right. Therefore, it is combination of type A and type B. It is combination of type A and type B. Combination of type A and type B chopper. Yes. This combination of type A and type B means, therefore, it is used for both forward motoring and forward braking control. Forward motoring and forward braking control. Then type A and type B, therefore it is two quadrant chopper. It is two quadrant chopper. Type B chopper is two quadrant chopper. Or it is also called two quadrant type A chopper. Then if you represent quadrant operation, V0 minus I0. This is forward motoring. This is forward. Here which device are operated? This is forward motoring, forward braking. CH1 and D1 is operated. In this circuit, CH1 and D1 is operated in first quadrant. Here which device are operated? This is forward braking. Here CH2 and D2 is operated. CH2 and D2 is operated. Okay. That means in this chopper, always V0 is greater than 0. But I0 less than 0 and I0 greater than 0. I0 greater than 0 is possible, I0 less than 0 is possible. But what about V0 is always greater than 0? Because V0 is always positive, na? But current is either positive or negative. Either positive or negative. Okay. This is two quadrant chopper. It is used for both forward motoring and forward braking control. Then this chopper is also called two quadrant type A chopper. It is a combination of type A and type. Okay. Next, type D chopper. Concentrate. Type D chopper. This type D chopper. This type D chopper is also called two quadrant type B chopper. It is also two quadrant but modification from type B. It is also called two quadrant type B chopper. Two quadrant type B chopper. Two quadrant type B chopper. Then what is the circuit we are using for type D chopper? This is load. This is assumed current direction. This is assumed load polarity. This is switch arrangement. This is diodes. VDC, that is plus minus V. Plus this is CH1. This is CH. This is D2. This is D. This assumed current direction, assumed voltage polarity. Yes. One operation. See, we can analyze this circuit by combination of chopper and diode also. That is one way to analyze. Then in that case, you take average under on condition and off condition, take the average of V0, take the average of I0, then we can analyze. That is one way to analyze. The another method is, we can separately analyze the circuit by using chopper is one pair and diode is one pair. Like that also we can. In that case, no need to take any average. I am explaining separately choppers one pair and diodes one pair. Okay. Then CH1 and CH2 is on. CH1, CH2 is on. Then CH1, CH2 on means D1, D2 is off. D1, D2 is under off state. Then what the equivalent circuit? CH1 and CH2 is on. This is CH1, chopper 1, that is switch 1, and this is the load. This is the load, and this is CH2. Okay. The supply voltage is VDC. Supply voltage is VDC. This is CH2. Okay. Then how this CH1 and CH2 will supply the current to the load? Tell me. This CH1 and CH2 will supply the current to the load like this. This is the direction. Same that of assumed direction or opposite direction, same assumed direction. What is I0? Positive. Where this is positive and this is negative. No? This positive wire is connected here. This negative wire is connected here. Same assumed polarity or opposite polarity, same assumed polarity. V0 is positive. I0 positive, V0 positive. Which quadrant? First quadrant. I'm not taking average. In the previous circuits, I take an average. But here, because this I taken one pair and D1, D2 is one pair. Then this is first quadrant. Sir, I want to analyze the circuit by taking this. I will take I0 positive, V0 positive. In the next case also, I will get what I will get. Then I will take average of that. Then I want to like that. If you want to analyze means you take CH1, D1 is one pair, CH2, D2 is one pair. Like that you can. No need of that. You take this I0 positive, V0 positive. That is first quadrant. Okay. But one operation is nothing but one on and one off. CH1 and CH2 is off. CH1 and CH2 is off. If CH1 and CH2 is off means D1, D2 will on. Here I0 positive, V0 positive. What is V0? You tell me. V0 equal to this VDC will appear across this now. This is V0. Then what is V0 equal to plus VDC in this case? Okay. Then what about CH3 and if CH1 and CH2 is off? CH1 and CH2 is off. If CH1 and CH2 is off, what about the D1, D2? D1, D2 will on. Then in this case, what is the equivalent? Okay, D1, D2 is on. This is D1. And this is load. And this is D2. This you take VDC. Plus, minus. Now, see the direction of current supplied by this D1, D2. The direction of current supplied by the D1, D2. Because D1 diode is represented like this, D2 diode is also represented like this. That's why it supplies the current in this direction. This current and assumed current, same direction or opposite direction? Same direction. That means I0 is positive. Okay. What about the polarity connected by source? This positive wire is connected here. This negative wire is connected here. This minus plus. But here assuming polarity is plus minus. See the polarity. This is minus plus. But what you are getting plus minus we are. This plus minus. This is minus plus. Then what is V naught? Negative. I naught positive, V naught negative. Which quadrant? Fourth quadrant. This is under fourth quadrant. I naught positive, V naught negative, then it is a fourth quadrant. Then what is V naught negative means what is V naught equal to minus V. Therefore, type D chopper is operated in which quadrant? First and fourth quadrant. Therefore, type D chopper. This is type D chopper. Type D chopper is operated in first and fourth quadrant. First and fourth quadrant. Hence, it is two quadrant chopper. It is a two quadrant chopper. Okay, it is two quadrant chopper. Or it is also called two quadrant type B chopper. Alternative names also important. Also in already in some competitive. Two quadrant. It is two quadrant chopper. Okay. Then first and fourth quadrant means like this. This is operated in first and fourth quadrant. This is the quadrant operation of type D chopper. This is V naught. This is minus V naught. This is I naught. This is minus I naught. It is operated in first and fourth quadrant. In first quadrant, forward motoring. This is reverse phase. Okay. Here which device are switch on? CH1 and CH2 is on. Here which device are on? D1 and D2 is on. Now, in type A chopper, it is a step down chopper. The average output voltage is similar to that of step down chopper. In type B chopper, it is a step up chopper. The analysis also similar to step up chopper. But type C is combination of type A and type B. Then both the formulas, both the type A and type B formulas we can use. But what about the formulas in type C chopper? For that, I want to derive the average output voltage of type C chopper. Yes, it's okay. Tell me. How to calculate average output voltage of type D chopper? Average output voltage of type D chopper. During switch is on state, during T on, what is V naught equal to? During T on, what is V naught equal to plus VDC? That is on and off means with respect to switches you take. During T off, what is during T off? What is V naught you tell me? Minus VDC. Then what is the average output voltage? Therefore, average output voltage. In the case of type C chopper, average output voltage V naught equal to VDC into T on by T minus VDC into T off by T. Shall we write like this? Then what is the average output voltage? Take VDC is common. T on minus T off by T. How to write T on equal to dt? T on is dt. This is 1 minus d into T by T. T cancel. What is V naught equal to VDC into, that is 2D minus 1 again. This is average output voltage expression in the case of type D chopper. V naught equal to VDC into 2D minus 1. From this, I want to write some observations important for computative. Tell. We are getting average output voltage equal to VDC into 2D minus 1. Okay. V naught equal to VDC in 2D minus 1. This is for type D chopper. For D, this analysis for type D chopper, not for type C. Continuation of type D, this one. Okay. For V naught equal to VDC, that is 2D minus 1. Then for D less than 0.5, what you can get, you tell me. For D less than 0.5, you can substitute here, we can get negative voltage. For D greater than 0.5, you can substitute here, what is V naught, you can get positive voltage. V naught is positive voltage. Okay. Then for D equal to 0.5, what is V naught? We can get 0. Okay. D less than 0.5 means T on less than T off. T on less than T off. D greater than 0.5 means T on greater than T off. D equal to 0.5 means T on equal to T off. Can I accept this one? D equal to 0.5. You write D equal T on by T on plus T off. D equal T on by T, on time by total time period. On total time period is nothing but on time plus off time. You replace on time by off time. Then we can get what we can get 1 by 2. Duty ratio is 1 by 2. That is 0.5. That means V naught negative means this area. Na? That when V naught is negative, D less than 0.5. D less than 0.5. D less than 0.5 means T on less than T on. This is which mode? Reverse braking mode. That means type D chopper is used to control the motor in reverse braking mode for duty cycle less than 0.5 or T on less than T on. D less than 0.5. D greater than 0.5, V naught positive. V naught positive means this area. Na? V naught positive means this area. That means for D greater than 0.5 means T on greater than T off. Then this is which mode? Forward motoring mode. Forward motoring mode. That means this chopper is used to control the motor in forward motoring for greater than 0.5. For any question we can expect. For duty cycle greater than 0.5 we can use this one for motoring control. For duty cycle less than 0.5 this is used for braking control. For D equal to 0.5 which area it indicates? Yes. For D equal to 0.5 means V naught is 0. D equal to 0.5, V naught 0 means this is the area for D equal to 0.5. It cannot be used for motoring. It is not used for braking. And this is the boundary between motoring and braking. D equal to 0.5 is the braking between, that is boundary between forward motoring and reverse braking. For D equal to 0.5, it never delivers the power. Okay, it is not used for braking. It is not used for motoring. Okay, D equal to 0.5 means T on equal to T on. T on equal. This point is important to answer any theory question. The another point to remember in type D chopper. In type D chopper means in type D chopper. What is the observation? I naught is always positive, but V naught is less than 0 and V naught greater than 0 is also positive. V naught is either positive or negative, but I naught is always positive. In that case, you take that chopper is which chopper? Type D chopper. In that case, you take that chopper is type D. Okay, clear? Concentrate with this. In the next class, we will continue with this session.